All right, pre-calculus 11, let's get after it. Here we go, video number 2. We are looking at factoring complex polynomials. So first video, we factored the basic ones. Now we're gonna look at ones that are a little bit more challenging. So here we go. What we mean by complex is that they have a leading term. So what we've seen so far is we've seen questions like this, where there's no leading term, so we just look for the two numbers that multiply to 6 and add to 5, and yay, that was so easy. Or we had a difference of squares, where it's like, oh yeah, x plus 2, x minus 2, so great. Or we had something that looked like this, where we had a leading term, but it turned out we could factor it out of our entire quadratic, which then gave us a remaining statement that had no leading term, and we could factor that the easy way as well. So what we're going to look at now is a quadratic of this form, where we have a leading term that does not factor out. So it's just an example, but something like that. Now, I'm going to show you two ways to tackle this. You'll learn two more as you continue through in PC 11, and there's probably even a couple more. There's a number of ways to factor quadratics. These two are probably my go-tos, though, so I'm going to show them here. So we have two methods. One's called the AC method, one is called grouping. Now, both methods actually have the same first step. The first step second step. The first method for the AC method is to multiply your A term and your C term, hence AC method, and rewrite your quadratic as x squared plus 7x plus 12. Now you'll notice what that does is that gives us a quadratic with no leading term. We then factor that as is. So this is the step that is the same. We're looking for two numbers that multiply to 12, add to 7. So for the AC method, we get 3 and 4. Now I'll pause there and I'll go over to grouping, because that's where grouping takes the same step. Intuitively, or in our head, we go, okay, we need two numbers that multiply to that product. So two numbers that multiply to 12 and add to 7. And from the question on the side, we know that it's 3 and 4. So for grouping, you split the middle term into those two values. So you go, okay, 6x squared plus 3x plus 4x plus 2. And then we'll come back to that one. So you can see that both of them are going to require that value. Now for the AC method, since we multiplied our last term by 6, we need to divide the two values that will give us our last term by the same amount. We then need to simplify those fractions, or else you're going to be in trouble, to that. Now the last step, which I'll elaborate on later, is the denominator goes above and in front of the x. So we finish with 2x plus 1 times 3x plus 2. And then you can check using FOIL to make sure you did it right. So for factor by grouping, we're at the point you see on the right there, and then we group the first two terms together, we group the second two terms together, and we factor out a common factor. So from the first two, the common factor is a 3x, and we're left with 2x plus 1. And then from the second two, the common factor is a plus 2, and we end up with 2x plus 1. So now you'll notice, as far as this is a product and this is a product go, this is a common factor in both. So we actually factor out the entire thing. So the 2x plus 1 comes out to the front, and we're left with 3x plus 2. So you can see, same thing, same thing. So both methods work. Find the one you like the most and are most comfortable with and use it. So here I'm only going to do the AC method, and on the next slide I'll only do the grouping method, and I'll show you why the denominators can just come up. So our first step here is to rewrite this as x squared plus 7x plus negative 8. And then the two numbers that multiply to negative 8 and add to 7 are x plus 8 and x minus 1. Then the important step, divide by 2, divide by 2. And the first one can simplify to x plus 4, so nothing to do there. And now here is where the 2 would come up in front of the x, and we get 2x minus 1. So you may be asking, well, why are you allowed to do that? Well, it comes down to the fact that when we start working with these things in graphical analysis, we will have them equal to 0 to solve for the roots, the values that, the x values when y is 0, right? So we're solving when 0. So if you set these things equal to 0, you can multiply the left and right by the same thing. So if you have a statement like this, and you just don't want that 2 in the denominator, Well, you would just multiply this side of the equation by whatever that denominator is. Remember grade 9 algebra. But I'm going to multiply it into this one instead of the first one. And you can do that because everything's multiplying together. And what you end up with then is you end up with x plus 4, and then 2 times x, which is 2x. And then the 2 cancels with that 2, so minus 1. And you'll notice we multiply that side by 2, but nothing changes because it's 0. And that's why you can do that. Do that to your heart's content. So next one, let's look at grouping here. So I'm looking for two numbers that multiply to negative 24. So an a times b, which is negative 24. And an a plus b, that's negative 5. So my brain goes, ooh, negative 8, positive 3. So I split that up. So now I have 12x squared minus 8x plus 3x. And by the way, the order of those does not matter. You can choose. You get the same answer in the end. It'll just be kind of reversed in its expression. And then minus 2. And then we set our grouping brackets and we factor out our common factor. So here you'll see something important. The first one I can factor out a 4x, and I'm left with 3x minus 2. And now you'll see I have that already. So can you just stop? No, you need to factor something out. But if you don't want to change it, you just factor out a plus 1. And then you're left with 3x minus 2. And then you factor out that 3x minus 2. So we get 3x minus 2. And what was left? 4x and a plus 1. If you don't put that in there, your whole question over here will be wrong. So just be really careful and then check using FOIL. So last one. What happens if you got something kind of nasty like this? Well, you might notice right off the bat that that is the same and it's a common factor and you can factor it out. And if you can do that, good for you. But as you're working on getting better at this stuff, declutter your question by using substitution and say, okay, well, why don't we let a minus 1 cubed be equal to a different variable? So let's say m. Just to make this question look less cluttered, we now have 25x squared m minus 5xm minus 2m. And now you'll notice, oh, well, I can definitely factor that m out to the front. And again, you don't have to do this if you're good and comfortable with this stuff, but it just helps visually. And now we're looking for two numbers that multiply to negative 50 and add to negative 5. So I'm going to use grouping here, and I know that those numbers are negative 10 and positive 5. And now I have to do my grouping. And again, just like last question, you'll notice that from the first one, I can factor out a 5x, and I'm left with 5x minus 2. And from the second one, I can't factor anything out, so I need to factor out a plus 1. 1 is their greatest common factor, because now I have 5x plus 2, or minus 2, 5x minus 2. Now at this point, I'll sub back in for the m, for what it was, and then I can finish my question with my 5x plus 1 times 5x minus 2. So for our pay grade, we're done. You will learn later on that that is a difference of cubes, and there is a method to factoring that as well. But we're not going to get into that here. So there we go. That's your refresher on factoring complex polynomials. You're going to see this come back again when we get to quadratics, and then you'll see it again and again and again as you start to graph multi-degree polynomials, because if we can break them down to quadratics, we can graph their last two roots. So it's handy there. But you'll see all that roll into play in the next couple months. Thank you so much. See you next time.